Hello, welcome back. Time to do the alignment of the tuner, or at least check the alignment. And I'm going to start with the AM first. Alright, so let's see what they tell us to do here for the IF alignment for the AM. So here they say, so MF kringen is the AF alignment basically. So they say to apply a fixed, so that's DC, a DC negative voltage of 2 volts between the cross section of R11 and R4 and earth. So you should connect the plus to earth. And then they say, yeah, you can, this voltage can be derived from a 4.5 volt battery through a voltage divider. But okay, I have a power supply, a DC power supply, so I can use that. Now, where is this cross section? Let's have a look at the schematic. So the cross section between R11, so this is R11, and R4 is over there. So yeah, that's this cross section over here. So they tell us to supply minus 2 volts between this point and ground. Now, I guess the reason why they ask us to do this is to disable the automatic gain control, I guess, because this line here is fed from, okay, I have a cable in the way. Give me a second. So see this line here, this is fed from the detector circuit, and it's also fed from the signal going to the magic eye. So this is a sort of indication of the signal strength, which is then going all the way back into the grid of the ECH81. So I assume that this is like an automatic gain control. And the reason why they want to fix us this line to minus 2 volts is, I assume, so that our alignment is not influenced by the automatic gain control. That makes sense. So that's what I did here. I have here my power supply, have it set to 2 volts, and then I have it connected here to this is the point, the cross section between the two resistors. That's that point over here, and ground. And as you see, I have them swapped around so that I have minus 2 volts over here. So that's the first thing done. Then they say us to connect a voltmeter between 0.4 of SK1. So SK1 is switch 1. I guess the SK abbreviation stands for schakelaar, which is Dutch for switch. So to connect a voltmeter between 0.4 of switch 1 and earth. So 0.4 is of switch 1 is over there. And yeah, that's basically just measuring the output strength, right? But instead of a voltmeter, I'm gonna use the oscilloscope and connect them just on the output here. And then the next thing they tell us is to detune fully cores 41, 36, and 31. Now, I'm not gonna do that either because the radio is still working fine. It's still receiving fine on AM. It will just be a bit of fine tuning that I'm gonna do. So I'm just gonna leave them where they are and adjust them for a maximum. All right, and then here we have the alignment instructions. So let me set this all this thing up, and then we can start the alignment. Okay, so I have everything set up here. I chose again this setup where I just put the tuner on its side, and I can do the adjustments on the bottom on the top side, and I can do all the input and all the connections on the bottom. As I said earlier, this tuner does not have any adjustments for the coils via the bottom. Everything is via the top. So yeah, I need to have access to both if I want to switch here my scope and my input signal for the signal generator. So I have my power supply supplying a -2 volt here to the cross section of the two resistors on the AGC. And I have the scope connected to the point that we just mentioned, the R1, no, the 0.4 of switch 1. Easiest way to attach is over there. And then they tell us to align the radio. So first step is to put the radio on medium wave and put the band spread on narrow. So that means the band spread button is not pressed. Then they tell us to put the tuning condenser or capacitor on a minimum. So I guess they mean here fully open. So see, that's what I have here, fully open. That means all the way to the left of the dial. And then they tell us to supply a 452 kilohertz signal via a 33K picofarad capacitor to the grid of B4. So that's what I did. I am supplying here a 452 kilohertz signal via this 33 picofarad capacitor here to the grid of B4. And B4 is the second EF89 here. It's basically the last IF stage before the detector. So we are applying here on pin 2 this 452 kilohertz signal. Now, note that they didn't specify anything about modulation. So they just say, yeah, you should just supply a carrier of 400, carrier, it's the IF frequency of 452 kilohertz, and then you should measure with a voltmeter here on the AGC line, basically the signal strength. At the moment, I am applying a modulation here, and you can see it on the scope. I'm applying 440 hertz tone. If I enable the amplifier, then we can also hear it. See, if I turn up the volume of the amp. Now, let's just leave it down, otherwise, then we don't have to hear the sound. Now, there are two ways to do this, basically. So you can adjust. Now, we need to adjust for a maximum. So I can choose here to leave the modulation on and apply and check here the scope for a maximum. Or I can disable the modulation, connect a voltmeter to the same point, and then check for a maximum negative voltage on the AGC. Now, then they ask us to adjust S42 and S41 for a maximum. So that is basically these, where are they here, S41 and S42. So these two coils here. And you see, so we are applying here the signal on the grid of EF89. And then we're adjusting here S41 and S42. And that's these two guys over here. Let's see what we get here. So it's not easy to get this perfectly in shot. I only have one camera, so I hope you can still see here the effect on the scope and when I adjust here the coils. So the left one is S41, the right one is S42. So they mention S42 first. So let's start with S42. And we are going to adjust here this for a maximum. And yeah, it's already going down. See, these coils are really easy to adjust. Yeah, it's more or less on a peak, right? So maybe I can increase the signal a bit so that I have a bit of a higher fidelity. Let me just increase the signal strength slightly. Maybe, yeah. Yeah, so this is more or less a maximum. Then S41. That's going down. That's also more or less a maximum. So these were perfectly fine. They were, yeah, perfectly fine. They were quite good. So this is done, quite easy. Then the next step is basically the same thing, but to the other EF89. So we apply now to the grid 1 of B3 instead of B4, and we then adjust S35 and S36. So now we're going to move our signal here from the grid of B4 to the grid of B3, and then we're going to adjust these two coils. Okay, so I moved the signal generator to the grid of B3, and obviously I had to drop down the signal level quite a bit, but I do now have nicely the signal on the scope. And the cores that we now need to adjust are these two over here. So again, this is S35, this is S36. Let's do S35 first. That's going down. That is going up. Yeah, we do have a bit of gain here. Let me drop the signal a bit more. Yeah, we have a bit of gain, but not much. I'm just gonna adjust the scope. Okay. Yeah, this should be fine. Then next one, S36. Yeah, also a very slight bit of gain, but not a lot. Okay, so this step is also done. Next step is, again, we're moving it one tube backwards, so we're not going to apply the same signal to the grid of B2, and then we're going to adjust S30 and S31. So B2 is the mixer oscillator, and here we're going to move the signal here to the pin 2 of B2. So we're going to move it from here to there, and then we're going to adjust S30 and S31, so that's these two guys over here. All right, so we are now here at the grid of the ECH81, and obviously I had to drop the signal level again, but we again have a nice clear signal coming in. Now we need to adjust S30 and S31, and that's these two guys over here. So let's see what we get. Again, we start, I think, with S30. Yes, indeed, we start with S30. That was the wrong way. Yeah, again, same thing. We have a bit of gain, but not a lot. And this one, wrong way. Again, same thing. Very small marginal piece of gain. So all in all, the entire chain, I think we get a couple of percentages, maybe 5% of gain, but yeah. It's to be expected because I didn't change anything in the components except for the EABC80 and yeah, the filter capacitors and some resistance on the plate of the EC92 and the Magic Eye, and then also the discriminator capacitor for FM. Yeah, all these things shouldn't influence the IF or the AM. Now, you do obviously have a bit of age in the components, so it's normal that it has drifted slightly. So this adjustment, yeah, seems logical. But hey, for a radio from the 50s, this was still really, really well aligned. So yeah, I could have left it just untouched. Now I decided to do it anyway because these coils here with the pins sticking out, they are really easy to adjust. They just put a ceramic screwdriver inside and you can twist them very easily. You don't have to remove any wax or anything. So yeah, because it was so easy to do and easy to adjust, I decided to do it anyway. Now the last step that we have here, focus, thank you, is here they tell us to put the band spread on wide. So that means I need to now push in this button over here. And then we should do the same thing as over here, but we should just readjust S30. So the last coil that we did, we should readjust it. Oh no, the first one, this guy over here. I'm just gonna adjust my scope a bit because the signal level dropped. Maybe, yeah, just gonna increase the signal level slightly. And let's see what we get here. Yeah, there is not much difference. This is probably just a fine tuning. And honestly, I don't think you will see a lot unless I maybe increase the signal level significantly. Yeah, there is not much of a difference here. All right, fine. I think we have aligned the IF of the AM. Okay, so the medium wave RF alignment next. So the first thing they say is the band spread switch should be put in the setting narrow. That's done. Next thing is signal strength. I'm just gonna come back to that in a minute. But dan they say hier, de wijzer moet bij minimumstand van de afstemcondensator ingesteld worden op het meest linkse merkteken. So this basically means that the pointer has to be at the minimum of the tuning capacitor, be set to the leftmost marking point. So this means, so at the minimum of the tuning capacitor, see, so the tuning capacitor all the way open. So I guess I was right what they meant with minimum. And then you have to put the pointer that it aligns with the leftmost mark. So here we have the pointer, and there, this little triangle, that's the marking point, and that's the leftmost marking point. And I can't put the pointer more to the left. So we need to shift the pointer a bit. I think it's maybe a centimeter, probably a bit less, that I need to shift the pointer to the left. So that's the first thing I need to do. So the pointer has been shifted due to some reason, don't know why. Maybe it was me when removing the dial glass, but I need to just make sure now that the pointer aligns here with this marking before we can continue. Yeah, let me see if this is gonna work. So it needs to go in that direction. It does shift quite easily. I think I'm shifting the pointer, but I'm not really. Yeah, it's moving. Just a little bit more. Oh, that's already too much. Okay. The pointer is now nicely aligning with this mark. So that's the good starting point for the tuning. Aligning the RF. Okay. I'm again gonna skip this part. I'll come back to it later. We're just gonna check here what we need to do in the table. So the first thing we need to do is they tell us to align shortwave 2. I do think that this is a typo, maybe like a copy paste or something from another alignment instructions, because they say here shortwave 2 and shortwave 3. This radio only has two shortwave bands, so that should be 1 and 2. So this is shortwave 1. So we should align shortwave 1, and then we need to put the tuning condenser on 550 kilohertz and supply a signal of 6.38 megahertz. Now, this might seem a bit confusing at first, but yeah, let me show you what they mean with this 550 kilohertz here. So here we have the dial glass again, 550 kilohertz. Yeah, where is it? All the dials here are in meters. So there is not a single, except for the FM, which is in megahertz, but all the AM bands, they are all indicated in meters, and the alignment instructions are all in kilohertz. So you should do a bit of conversion. Now, 550 kilohertz is not in the shortwave 1 range. That one is actually in the medium wave range. And if you convert kilohertz to meters, 550 is more or less the crossing point. So 550 kilohertz is also more or less 550 meters. So let's check here, and here we see, yeah. See, you see that notch over there? That's 550 meters. And also, yeah, more or less 550 meters, but it's 550 kilohertz. So what they basically tell you is you should put the pointer here on that indicator, but you are aligning here this band. See, there are no indicators on any of the other bands. The indicators are only here on the medium wave band. So you should use these indicators just to put the dial pointer. That's why they say you should put the dial pointer on 550, even though 550 is not in the range of the shortwave. So let's just do that. So voila, we have now the dial pointer here exactly on the indicator for 550. And now they ask us to supply a signal of 6.38 megahertz, because here is what we are actually aligning. That should be 6.38 megahertz. Now, what I'm going to do here, I'm going to use this old boy here to do the alignment. Yeah, just for fun, because that one I can plug it in directly into the antenna input of the radio, which is convenient. And it also goes quite high, so it goes easily to 6.38 megahertz. The only disadvantage is, as I already explained in some of my earlier videos, the dial pointer is not that accurate, except on, especially on the higher megahertzes. So on the lower ones, it's easy to use it as an aligning tool, but on the higher ones, it's quite inaccurate. For example, how can you here? So see, this is 6 megahertz, that is 7 megahertz. How the hell can you put this on 6.38 exactly? So that's why I connected the signal generator to my scope. And the signal generator, if you have checked the previous video, you'll know about this. But the signal generator has two outputs, one low output and one high output. I'm using the low to go to the radio, and the high output is connected to the signal generator. And then, because then the low output is really quite low for the signal generator to accurately detect. So the high one, I connected that one to the signal generator, and then I'm simply using my signal generator as a frequency counter. See, I now have at 6. It's basically 6.38. Right, so that's how I make sure that the signal output of this old boy over here is really accurate. I'm just using the the oscilloscope. Did I say signal generator earlier? I'm using the oscilloscope as a frequency counter, basically. So let's see if we can find that 6.39 or 6.38 megahertz. Let me turn up the volume. Yeah, it's not there. Let's see if we can find it. I think there it is. Yeah, I don't have modulation active at the moment. But see, there it is. Let me turn on the modulation. Yeah. So, yeah, I disabled the modulation on the signal generator to be to easier get the 6.38 megahertz accurate. But you see, it is just slightly next to it. So it's quite good. We can just align it very slightly to get it spot on. Okay, so now about this sentence that I say over here. Just want to quickly come back to that. They say that you should. So they say that you should have the signal strength of the signal generator in such a way that the maximum reading on the diode voltmeter is more or less 50 millivolts. So remember the place where we connected the scope. So this 0.4 of switch 1, which is basically you have an indication of the signal strength. There they requested you to connect the diode voltmeter, but we have the scope there. You should read more or less 50 millivolts there. Now this is nice that they put this kind of reference here, but for me it's really difficult to really use this reference because a diode voltmeter is something which is a quite old type of test equipment. Philips made also these types of voltmeters. They used tubes inside, and I think they use a diode tube inside then to rectify the AC voltage and to give you then measure the AC voltage in that way. Now, obviously, my voltmeter doesn't do it like that. The scope is also not easy to use here as a measurement here. So I'm just gonna adjust the signal strength here of this signal generator based on what I get on the magic eye. So see, I now tuned into the signal, and then I adjust here the signal strength on the signal generator, and you can see clearly that the magic eye is opening and closing, and you just want to put it maybe like this so that it doesn't oversaturate the AGC. So just that you have a good signal but not overdoing it. That's basically it. It's just to align the RF. It doesn't really matter that much that it's really super accurate. So then they ask us to adjust S23 and S10 for a maximum. And S23 is this guy, and S10 is this guy. Let's have a look. I moved the dial exactly here onto the indicator. These guys seem a bit stuck. Yep. This one seems quite stuck, and this one. Yep, this one as well. I'm just gonna leave it like it is. It's like 1 millimeter off. Knowing the reputation of these Philips coils, I'm not gonna risk it. Okay, so for the second step, this is, they put here shortwave 3, but that's shortwave 2. They again tell you to put so you should keep the pointer on the same position, but now you should feed a 1.72 megahertz signal. And then you should adjust S20 and S8. So that's what I'm doing here. As you see, I have here a 1.72 megahertz signal feed in from the signal generator. And then you see here, so I have it now on shortwave 2. Then you see here that if I tune the radio, it's slightly off, I think. Again, slightly to the left. We just reduced the signal strength again a bit, but it's slightly to the left. If I enable the modulation, you can hear it as well. See? So both the shortwave 1 and the shortwave 2, they are just a tad to the left, and also shortwave 2 has the same coils here of Philips. So just gonna check if maybe everything is a slightly a bit to the left, then I can just move the dial pointer a bit, and then it's also solved. So the next step is put it on medium wave and feed in a 550 kilohertz signal and put the dial pointer on 550, obviously. So medium wave, that's this guy over here. Now let's put this one here on 550. That's band B, and we should have it. Am I right? Yeah, band B indeed. And let's check the scope. $565, that's already not bad. Let me adjust here this one until we have 550. Almost there, yeah. That's pretty good. Oh. $550.3, that's fine. Let's see where we get it on the dial. Okay. Maybe I'll just enable the... I can already hear it. Oh, it's way out. See, it's way out. Well, way. Maybe 3-4 millimeters. Okay, so the first one that they tell you to adjust is S25, and S25 is this guy over here. Now this is also such a coil and it's also quite stuck, but I did manage to get it loose, I think. See, if I enable the modulation and I tune into the signal like this, let's turn up the volume a bit, and then I turn this guy. Yeah, you can't hear it, but I can clearly see the magic eye changing here. And I can also see on the scope that the signal on the AGC line, that it is also changing. See, now the signal is completely gone. And I'm basically, if I now turn the dial here, okay, I went in the wrong direction, so I should turn it to the left. I'm just doing this very carefully because I don't want to break anything. See, I'm now, voila, now I'm tracing the signal here to the left. Actually, using the magic eye to do this is even the easiest. Let me just go straightly above here that I can clearly see what I'm doing. Okay, I now have the pointer aligned exactly on the indicator. Okay, that's a bit too far. This is a peak. Yeah, this is a peak. Okay, so next step here is to adjust S12 and S15. But here they say at the same time you should dampen with 1 kilo ohm the other one. So if you're adjusting S12, you should dampen S15, and when you're adjusting S15, you should dampen S12. See, so here we are on the schematic. This here is S12 and this is S15. So we're gonna start by adjusting S12. So I should dampen here S15. So I'm going to connect here. So I guess they just mean that you should put a 1 kilo ohm resistor across this coil to dampen it. And so the easiest way to do that is you just follow this line over here, and you see this is 0.7 of switch 5. See, over here is marked SK5, so everything on this line is all switch 5. So one side of the coil is basically connected to 0.7 of switch 5, and the other side of the coil is connected to 0.12 of switch 5. So if you put a 1 kilo ohm resistor across or between these 2 points, that should dampen S15, I guess. So I have here my 1 kilo ohm resistor, and see, there it is between these 2 points on the switch. And let's see what we get. Now, this is S12, and this is one of those easier guys to connect. So I'm just now here checking on the scope. I know that you can't see it in detail, but I'm just checking here on the scope and on the Magic Eye what this is doing. And yeah, this is making quite a difference. Okay, let me just turn up the modulation and the volume. See, you can hear this even. So, and I can also easily see it on the Magic Eye. And I'm also checking here the volume on the scope. The voltage on the scope. And I'm just trying to peak it here. Now I'm dampening the other side here, S12. So we're now gonna adjust S15, where it is here, S15, and then we should dampen S12. And it's also it's a bit more tricky. One side here is quite easy. If you follow that side, you can just connect it to 0.5 of switch 5. The other side, yeah, there we gonna need to figure out where is capacitor C75, for example, or C9, one of the two. Okay, so I found them. The white one is connected to pin 5 of switch 5. The yellow one is connected to the cross section between these two caps. This is C9, I think. Yeah, this is C9. So that should dampen S12, I guess. All right, so let's see if this makes a difference. This time I'm gonna show you on the Magic Eye. And this is also one of those easy coils to adjust. Whoa, yeah, indeed. Quite a big difference actually. And as you see, I can look at the voltage on the scope, but it's really just the easiest to do it with the Magic Eye. That's more or less a peak. Okay, next up is the long wave. We have only 1, 2, 3 steps into the 8-step procedure, and then they say at the end, yeah, do it one more time. I don't think I will do that, but okay, let's get on to the long wave. Yeah, again, the pointer should be at the same position, but this time we're gonna apply a 158.5 kilohertz signal and see where we get it. Okay, so the scope is now at 158.5, and also as you see, this one is also quite off. See? It should be over there. And it's also quite off. So, yeah, this one also needs a bit of an adjustment. And the first thing that we should do is S27. S27 is this one over here, so that's also an easy one to adjust. And yeah, I'm just gonna first do the same thing as I did before. I'm just gonna run the signal up to through the dial to get it in its correct place first. Okay, let me turn on the modulation for this. And it's this guy over here. And let's see on what direction we need to turn. I think to the left. Yeah. Now the dial pointer is exactly here on the indicator. And there we have it. Now, the next steps here for long wave are adjusting S14 and S16, and again we should put here a damper on S15 and S12, so that's the same ones as we did before. So let me just apply here the damper on S15, and then we're gonna adjust S14. Okay, and S14 is this guy over here. Should also be an easy one to adjust. If I can get my screwdriver in. Come on. I'm using the wrong one. Yeah, I can clearly see a difference. But wow, it's very wide and there is a lot of leeway on this one. It's not making a lot of difference. Yeah, this one is clearly in the wrong direction, but then once you hit a point like this, there is no increase anymore. Wow, it's really difficult, this one. Yeah, this is clearly worse. The more I turn it out to the left, the lesser the signal is becoming, but now it's increasing, and then I hit, maybe I should decrease the signal strength here a bit. Ah, yeah, okay, if I decrease the signal strength, I can get it a bit stronger. But here it achieves like a point of saturation where it doesn't become stronger anymore, so I'm just going to leave it where it hits the peak, which is something like this. So same thing now for the next one. I dampened S12, so I changed the damper, and I now should adjust S16, which is this one over here. And if my screwdriver can fit in, then we can see what happens. I think that does, yeah, that makes a huge difference. Well, not huge, but clear difference. That's maybe the better word to say. See that it's going back in the wrong direction. And this is the peak. All right. So that's the long wave adjusted. Now, all that remains is doing more or less exactly the same thing, but on the other side of the dial. Now, I don't think I will film everything here because, yeah, you've seen this. This is really similar. Maybe only the first one. So here you notice they say you should put now the dial pointer at 1500 kilohertz. Now again, this is on the medium wave band. And 1500 kilohertz is more or less 200 meters. So, and the 200 meters is that indicator over there. See, this is 210, that's 190. So this indicator over here is 200 meters. So we're going to put the dial pointer here on that one. And now I'm gonna put the tuner back on shortwave 1 and supply a 17.1 megahertz signal, and we're just gonna check where it's located, where we can find it. Okay, so I have the signal generator set to 17.1, as you see over there. And as you can see over here on the dial, and you have to look here on the indicator on the left, let me just turn on the modulation. Then you see yeah, it's also a bit off here to the left, so let me see if I can pull it in as well. So this side of the dial is a bit different because now we need to adjust capacitors. See, we need to adjust C30 and C7 for a maximum. So let's start with C30. And C30 is this guy over here. And I don't know any other way to adjust it than simply by hand. Let's see if this makes a difference. Yeah, clearly. Now let's try to figure out in which way I need to move it. to the left. Let me just put the dial pointer here exactly above the indicator, and then we'll put it correctly. So this is the dial pointer exactly on the indicator. If I don't have any parallax, yeah, indeed. And now let's move this one until we have a maximum and we hear the signal. There it is. Yeah, you might not, it might sound like it's not a maximum, but this is not a maximum good signal. This is distorted, and here on the magic eye, it clearly shows that the maximum is exactly over here. Okay, and C7 is that guy over there. So in between the coils here are capacitors, and that's that guy over there. Let's see if that makes a difference. I can hear it make a difference, but cannot see anything on the magic eye because that one is maxed out. Huh. The magic eye is really maxed out, so the signal that I'm putting in there is too strong. So I just now unplugged here the signal generator from the antenna, and I just loosely put the wire here next to the antenna connection, and yeah, this is better. And this one is clearly making a difference. Okay, that's the peak, more or less. Okay, that's the peak. Okay, so I think you got the point, right? Let me just go through all these remaining steps here. So see, for the next shortwave, I should apply 4.75 megahertz, and then I should adjust the capacitors C26 and C5, and then the medium wave and the long wave. And again, you need to dampen here the coils S15 and S12, and then adjust these capacitors. Yeah, so let me just go through all this and then show you the result afterwards, because otherwise it's just gonna be way too long, this video with all the same things. I mean, this RF alignment procedure is really huge compared to some other radios that I've done. So yeah, I think you get the point now, right? Okay, so I rechecked all the alignments. I adjusted again a couple of things that I noticed, because by changing here on one side of the dial, the other side shifted a bit, so I corrected some things. I did all the remaining parts here of the left side of the dial for the shortwave 2, medium wave and long wave. I also managed to get the S23 coil unstuck, so I managed to align shortwave 1. Shortwave 2, that one was really stuck, so I left it like it was. That was basically the S20. Here is basically the only coil that I couldn't do. For the rest, I managed to align everything as good as I could. Yeah, man, this is really a lot of work. This procedure is really extensive, and so you have to check everything twice. It's really a lot of work. It took me really a couple of hours of time to do this fully. Yeah, and thinking that I'm probably never even gonna listen to the AM, but okay, it has to be done. So the sound that you hear right now is just the rain on the roof here. It has been raining really heavily here the past couple of days. But let's see if we now actually receive something. I don't have a dedicated AM antenna here at the moment. I just have my FM dipole connected and then the switch set here so that it's also used for AM. So it's not optimal. It is quite late in the evening, but yeah, there is also a bit of interference probably, and all the stations here are very far away. There are no local AM stations anymore here in Belgium. So don't expect any miracles, but let's see if there is at least some reception. Let's start with the long wave. Pull up the volume. Since we lost RTL, I'm not expecting anything here. Yeah, I just turned off the light because that caused quite a bit of interference. Okay, let's see what we get here. Yeah, that's BBC World Service, Droidwich. That's the only thing I expect here on long wave. Let's do medium wave. I have to put up the volume a bit.
¿Por qué? Porque ha venido una herramienta tecnológica que ha revolucionado el fútbol, que se llama VAR, pero en cambio el reglamento sigue siendo el mismo.
Okay, shortwave 1. The interference is really horrible. Yeah, this is the 49-meter band, I think. Yeah. So there should be some things in there. Yeah, voilà, see? That's actually receiving quite well. Shortwave 2. Is this an amateur band? I guess so. Okay, I guess that's it for the AM alignment. Whew, that was a hell of a job. Yeah, now I guess the FM is up. Now the FM is working quite well, but I did change the capacitor for the detector, so I do want to check the alignment. I also changed the EABC 80, so that's another reason to recheck the alignment. Well, at least check the detector and also check if the dial is correct, but because I also think it's a bit out. So yeah, that's the next thing to do. Okay, I think that's more than enough for this video. I think it's already running quite long, I guess. Yeah, this was way more work and there was way more interesting content here on the AM part of this tuner than I expected. But yeah, I hope that you enjoyed it anyway. I certainly did. I learned quite a couple of new things. I was quite impressed by how the layout here is done for the tuner, all the AM sections, how yeah, extensive they are and how extensive all the bands are made. So yeah, that was quite nice to see. In the next video, we'll do the FM alignment. I think that should be shorter. And I also don't know yet how the course will react. So it could be that I'm not aligning it. I'm just going to check the detector. Is it going to be well balanced? And then because the AM is working pretty well, I don't want to touch it too much. And if you're still awake after this long video, I'd like to thank you for watching. If you like the content, please subscribe, like the video, hit the bell button that you get notified when I post a new one, when I post the last video in the series here. And then I'll see you then. So take care. Bye-bye.